I'm here to show you a dynamic power factor correcting unit from Energy Saver. Basically, the way this unit works is it looks at the line and determines how much capacitance to put in the line to bring the power factor to unity. As we can see, we have a 5 microfarad, 10 microfarad, 20 microfarad, 45 microfarad, and 90 microfarad capacitor in this unit. And the unit is currently on. As you can see, it's currently on. It is plugged in right here. The CT set in line, and here's our power source coming from the wall. Basically, the unit does not draw any amperage while there are no motors running while the unit is plugged in. Okay, we have a simple setup here where we just have a power strip, and we're going to plug in these 3 motors here, which are these 3 motors here, 2 1/8 horsepower motors, 1 1/3 horsepower motor, and here are the plugs for the motors. And we keep it simple. We basically don't want any switches or anything where somebody could go in there and rig the switches to do this or do that while you turn it off or on. So we just have power wires going right into motors. Right here, you plug those right into the power strip. And we're going to show you by unplugging the unit, the dynamic unit, plugging it in, how it works, and how it does not draw any power while it's plugged in. Okay, so let's go ahead and plug in one of these motors here. And as you can see, the 1/3 horsepower motor turned on. And right now what's happening is the dynamic power factor correcting unit is determining how much capacitance to use. So it's turned on the 90 microfarad and the 10 microfarad unit. Okay, so let's look down here. As you can see, there's 1.87 amps being drawn by this 1/3 horsepower motor. Now if we come over here and unplug the dynamic power factor correcting unit, you're going to see that amperage jump up dramatically. Okay, let's go ahead and plug back in the dynamic power factor correcting unit, and you'll see that amperage drop. It takes a couple seconds. The dynamic unit has to do all of its calculations and determine how much capacitance to add to actually bring that power factor up to unity. Okay, as you can see that we've done that and it's happened. Now let's plug in another unit. As you can see right here, we have a 90 microfarad and a 10 microfarad capacitor, and it's calculating right now. It says, okay, we need 5 microfarads instead of the 10. We're going to plug in another motor. Okay, this is the second motor, 1/8 horsepower motor right there that turned on. And if we look up here, we can see that now it's turned on the 20 microfarad capacitor and the 10 microfarad, and it also has the 90 microfarad on. Okay, let's look down here, and we're going to go back down and unplug the dynamic unit. Okay, just so we can see how much amperage jumps up. Okay, the dynamic unit is turned off. There's no lights on. The amperage has jumped up. I'm going to plug that back in here and give it a second. It's actually coming up here, doing its calculations, adding the proper capacitance to bring it to unity, drops the amperage back down. Okay, now let's add one more motor here. And basically what we're just showing is how this unit, this dynamic power factor correcting unit, is smart, and it's actually going through and calculating the power factor and then adding the proper capacitances again to bring this up to unity. Okay, so now we're at 2.38 amps. We can see we have all 3 motors, this motor, and that motor spinning. And so all 3 of those motors are running. We're going to disconnect the dynamic unit and watch an amperage go up. 2.38 to 7.47 amps. Wow, that's a big jump. That's 5 amps jump right there, over 5 amps. Okay, now we're going to plug back in the power factor correcting unit. I just want to show you right here, power factor correcting unit is off. Plug it back in. And give it a second. It's doing it all its math and calculations. 2.48. Now the most important thing is the power draw of this unit. Okay, so we can see right now that it cuts down from over about a 7.5 amps down to 2.36 amps. What I'm going to do, we're going to leave the dynamic unit in, plugged in, okay, not changing anything. We're going to leave all the power on, okay, but we are going to remove the motors. So when, for example, if you're in a business and at night everybody goes home and all of these motors get unplugged or turned off and we can hear the noise, the unit is still plugged in. We still have power on the unit right here. Okay. Now let's go down and look at the amp draw. The amp draw, 0.01 amps. And as you can see, the unit's still plugged in, nothing has changed. Power strips plugged into here. Basically what had happened is the dynamic unit determined it did not need any more capacitance and shut everything off inside. It's just kind of in standby right now, waiting for a load to be plugged in. So that kind of concludes exactly how the dynamic power factor correcting unit works.